In the previous videos, we covered about SI units and then we covered prefixes. What are prefixes? And this video is about the rules for writing SI units and prefixes, because in physics we are dealing with physical quantities with huge numbers. We are writing SI units and prefix at the same time. So there are some rules that you need to follow in order to avoid any confusions. So this will be, I'll try to make it video as short as possible. As you can see, I made a presentation, some kind of a bit of a presentation for it, because I've noted that my whole videos, previous videos take a lot of time, and mostly it's when I try to write down the definitions and everything, so it takes a lot of time. So I made some presentations, and if this goes well, I'll be sticking with presentations, and I will give the kind of this lecture on the slides. So enough of that. Today's videos will be as the slide so it shows. I'll be talking through the 5 important rules for writing SI units and prefixes. Now there are more than 5 rules, but generally I think that these 5 are most important, that you should keep in mind in order to avoid any errors or confusions. Let's go through the first one. So this one, just give me some time to adjust. Okay, now 5 key points here. What are the 5 rules? And these are the 5 key points, kind of I wrote it down for you. First will be symbol and full name of base units. The second will be the plural form, which also goes with the symbols of SI units and prefixes. Number 3 is multiple prefixes. Number 4 is mixing the SI units. Number 5 is raising the power. Basically, both raising the power are both the SI unit and the prefixes. So let's get going, shall we, to the first point, which is the symbol and full name of base unit. Okay. So number 1 is symbol and full name of SI units. So the full name of base units are all written in small letters. The full name of base units are always written in small letters. But for symbols, in case of symbols, the first letter is written capital only if the unit is named after a scientist. For example, we have the unit of force, which is the SI unit of force. His full name is Newton, and his symbol is written by N. So here, Newton, I already know it's the full name. Let me write it down, which is the full name, and its symbol is written capital. So capital, which means that it's named after Isaac Newton. So that's why the symbol is N. Let's have another example, shall we, in which is not included in this slide. Let's say unit of length. So what's the unit of length? Please excuse my not so good writing. So what's the unit of the SI unit of length? We know that is meter, so the full name is meter, and its symbol is given by. So meter is not named after a scientist, so it's written as only small m. So small m, and the full name is always written in smaller letters. So I hope you get the idea. The first point is that the symbol is only written, first letter is always written capital only if it's named after a scientist, and the full name of SI units are all written in small letters. Let's go to the second point. Okay, the second point is plural form. So the symbol of base units and prefixes do not take plural form. Basically, take this example. We have 1 kg, which is correctly written. But if you take plural form, why did I write here 1 kg? Um, let's say it's 2 kg, because I don't think there's a plural form for only one object. So let's say 2 kg. So for two more than one, you might be thinking that we should add s with it, with plural, so it becomes a plural. Wrong. This is totally wrong. Because why? Because in physics we are dealing with physical quantities, so the symbols are the key. So what do I mean by that? Well, you can see it below. 1 kg is written as 1 kilogram, but when we put 1 kgs, it just alters the meaning of it. So here we are writing with the intention of making it plural, because it's more than one. Obviously I've written here too, but when we were dealing in physics, any person who's a teacher or some or dealing with physics problems, he's gonna notice it, and it's gonna say no, it's not written as 1 kilograms. It's basically written as 1 kilogram second. As you know that s in physics stands for capital, the small s symbol stands for the second here. So he's gonna take that he has written as that the student or someone has written here second. So this will be totally wrong. So that's why you need to be careful of it. Also the same goes with the the symbol of prefixes also. But when talking about full names, you can always add it. For example, 7 kg, when written fully written, you can add it. So no problems there, because we are writing in full name. So it makes clear for us. But when we are dealing with symbols, plural form is a red sign, red signal, stop, because it's gonna make another meaning of it, which is in this case kilogram, kgs, as gonna stand for the second. Third point is, let me adjust the slide. Okay, wait. Okay, multiple prefixes. So what do I mean by multiple prefixes? So multiple prefixes, more than one prefixes, are not allowed. Totally not allowed. Only a single prefix is used. Here I have given an example that 7 terabyte is written correctly. But if you try to introduce multiple prefixes, like here I have written two symbol, the prefix symbol, which is megabyte, it's totally wrong. So here I didn't give you the numerical form, so it's basically saying times 10 power 12. I was about to write minus 12, so it's wrong there on 10 power 12. So here the correct is to write it as a single prefix, which is 7 terabyte, instead of writing 2 megabytes. So megabyte, you already know, 10 power 6. 10 power 6, 10 power 6. So you might think this is correct, but this is wrong. And it doesn't matter even if you take two same prefixes or two different kind of prefixes, it will always be wrong. Only use a single prefix. Now on to the fourth one. Okay. Let me adjust the slide. Okay. Mixing units, mainly dealing with SI units and the standard units. So do not mix base units with any other non-standard units. Basically it's saying that, hold up, do not mix the SI units with other non-standard units. For example, when we already know that the SI unit for length is meter, do not mix it with another unit of length which is not SI, like feet, etc. So how do we deal with it? The question remains then, how do we deal with when the initial units that are given to us are non-standard units, that are not SI units? So there are two approaches. So let's read the second point here. If the measurements are in non-standard units, then either first convert them, this is the point here, either first convert them into base units or convert the end result into base units. So there are two approaches. Either first convert it, here we have given an example. Let's take this one, shall we? So here have written 1 feet plus 1 feet, which is the non-standard unit for length. So either you can convert in the first place feet to meter, which is basically 1 feet is approximately equal to 0.3 meter, convert them into SI units and then add them up. Or you can take the second approach, which is also convenient, which is also equally they are equally better. You can take any approach you want, which is 1 feet plus 1 feet, add them up 2 feet. Now in the end result, just convert the 2 feet into the SI unit, which is meter, 0.6 meter. Now on to the last point, last one. I'm just trying to make that this whiteboard doesn't show up. Excuse me for a bit. I think I can't because this is the end of the slide. Anyways, the last point, raising power. When a multiple of base unit is raised to a power, the power applies to the whole multiple and not the base unit alone. So this statement is kind of tricky, but I'll explain it to you as simple as possible, that when any base unit is raised to a power, the power doesn't only apply to the base unit alone. If there's a prefix, then it will apply to the prefix 2 also. Here I have an example, simple example of it. 1 kilometer, as you can see that there is a brackets and between them it's kilometer, and we already know that this is square, power 2 square. So normally, let's look at the right side, shall we? So normally some people will think that that the square will apply only to the meter itself, but this is totally wrong. This is wrong because we already know if something is enclosed in brackets and it has square power outside it, then this power that the square will apply to the whole of it. So the correct approach is here, this, which is 1 kilo square m square. So it's kilo square, which basically means k and k, which is 10 power 3 dot 10 power 3. So basically they're gonna add up, and here we have the result, which is 1 times 10 power 6 m squared, which can also, if you apply prefixes, can be 1 mega m squared. So please excuse me for the sudden cut of the video section because had some problems here and there. So this is the end of this video, and if you have any questions you can comment down below and I'll try to answer it for you. And if you enjoyed this video, found it informative, so don't forget, if you have found this informative, then don't forget to like, subscribe and share it with everyone. And I'll see you guys in the next video. Thank you.